just figured out how to divide algebraic expressions and now you're being asked to do the same with complex numbers? If this stopped you in your tracks, make sure you keep watching this video as I show you the most efficient method to solve these problems. Hi, I'm Mary, I'm the girl who loves maths. Welcome to today's lesson. If you haven't already, please subscribe to my channel to be the first to know when my weekly videos are released. In this video, I'm going to teach you how to solve complex division problems that look like this using something called the complex conjugate. Before we jump over to my iPad, make sure you download the free notes that accompany this lesson. The link for these can be found in the description section below. Let's get learning. So let's kick things off with this example. We have 3 plus 4i being divided by 2 minus 5i. The first thing I'm going to do is put a set of parentheses around the numerator and the denominator. For us to simplify this fraction, we're going to need to multiply both the numerator and the denominator by the conjugate of the denominator. So our denominator is 2 minus 5i. The conjugate of that is 2 plus 5i. Let's tidy this up a little before we move on to our next step. Let's use our FOIL method to expand out each level of the fraction. If you need a little bit of a recap on the FOIL method, please check out my video on multiplying complex numbers. Let's now collect our like terms and simplify. Whilst we're simplifying, we need to recall that I squared is equal to -1. In simplifying our numerator, we have 15i plus 8i. That's going to give us 23i. And then, of course, we need to add on our 20 multiplied by -1. As we know, I squared is equal to -1. Onto our denominator, we have our 10i minus 10i. That will just give us 0 i's, which we don't need to write. And then, of course, we have our 25 multiplied by -1. Again, as I squared is equal to -1. Let's tidy this up a touch by simplifying these sections of our fraction. A touch more simplifying, we have our 6 minus 20. That's going to give us -14. And 4 plus 25 gives us 29. To write this conventionally, we're going to split our fraction. We'll have -14 on 29 plus 23 over 29i. This here is considered standard form. And when I refer to standard form, I mean it's in the form of our real part of a complex number plus the imaginary part with our I at the end. How about we go now and take a look at another example. In this question, we're being asked to simplify 2 plus 2i over 1 minus I. The first thing I'm going to do is pop a set of parentheses around both the numerator and the denominator. Next, we need to multiply both the numerator and the denominator by the conjugate of the denominator. Since our denominator is 1 minus I, the conjugate is 1 plus I. Let's rewrite this. And using our FOIL method, we'll expand out the parentheses. Let's now simplify the numerator and the denominator whilst recalling that I squared is equal to -1. Let's focus on the numerator first. Our like terms are 2i plus 2i, which is going to give us 4i. And then, of course, we need to add on our 2 multiplied by -1. Onto the denominator, our like terms, positive I minus I, they're just going to cancel out. And we need to ensure that we substitute -1 into our I squared. Let's move on over here and continue to simplify. A touch more simplifying to go. You'll see on our numerator we have 2 minus 2. That's going to give us 0, so we're just going to be left with our positive 4i over 2. This breaks down to give us 2i, And there is our solution. Okay, so that sums up complex division for you. If this video was exactly what you were looking for, please let me know by giving this video a thumbs up. Share this clip with any of your classmates who might also find this video helpful, and don't forget to pick up your free notes that highlight what today's lesson was all about. The link for these can be found in the description section below. Thanks for watching. I will see you in the next video. Bye.